For our project, Haley and I went to the beach boardwalk to demonstrate various physics concepts. First, we went on Firefall.
Motors were used to take us higher and higher, and we built gravitational potential energy as we rose. The ride swung back and forth in a pendulum motion, and when the swing was at its highest point, the ride possessed the largest quantity of GPE, due to the fact that we were elevated at such a high level above the ground.
Although obtaining the mass of the ride, as well as the passengers on the ride, is rather difficult, in order to calculate GPE, you multiply the mass by gravity, 9.8 meters per second squared, and the height of the coaster. As the ride dropped, it lost its GPE due to the loss of height. The gravitational potential energy transformed into kinetic energy, or the energy of motion. The amount of kinetic energy was equal to the initial GPE, so in order to calculate the velocity at which we were traveling, you would set the energy equal to 1/2 mv squared and solve for velocity.
The second ride we went on was the Drop Tower. The Drop Tower demonstrated part of Newton's first law. An object at rest will stay at rest unless acted upon by an outside force. The cart stayed in place at the bottom of the track until the motors pushed the cart upward.
The next ride we went on was the Cliffhanger. When the ride moved, centripetal force pushed inward on us toward the center, keeping us in circular rotation. Since the ride moved slowly enough, the centripetal force of the ride kept everyone on board.
In order to find centripetal force, you multiply mass by velocity squared over the radius of the ride.
In theory, if the ride started moving really fast, centrifugal force, which is the apparent force that acts outward on a body moving around a center, arising from the body's inertia, would take over and break the centripetal force the platform had on the riders, and the riders would fly off. However, centrifugal force is a fictitious force.
The final ride we went on was Undertow. Undertow demonstrates Newton's third law, which states that for every action there is an equal and opposite reaction. The size of the force on the first object equals the size of the force on the second object. That being said, the force of our cart on the track was equivalent to the force of the track on the cart.
Thanks for watching!